problems here and see how you're doing on them. So for the first one, we have 12 fluid ounces per second going into quarts per minute. So I'm going to put my 12 fluid ounces on top over 1 second. Now I have to get rid of fluid ounces, so I'm going to put fluid ounces on bottom. And I'm going to go to cups. 1 cup is 8 fluid ounces. Right now we're in cups per second, so I have to keep going to get rid of cups. 2 cups is 1 pint. But we're now in pints per second, so I need to go one more step to get rid of pints. Get to quarts. 1 quart is 2 pints. So now we're in quarts per second. We have to change the seconds. The seconds are on bottom, so we're going to put them on top to get rid of them. Going into minutes. 1 minute is 60 seconds. So the seconds cancel out. On top, we have 12 times 1 times 1 times 1 times 60. So that's going to be 720 quarts. On bottom, we have 1 times 8 times 2 is 32 minutes. That's 720 quarts divided by 32 is 22.5 quarts per 1 minute, or 22.5 quarts per minute. Second one, 3.2 pounds per gallon. 3.2 pounds per 1 gallon is what we'll start out with. We get rid of the pounds. We're going from pounds into ounces. We're going to put pounds on bottom. 1 pound is 16 ounces. So the pounds cancel out. We're now in ounces per gallon. We want ounces per pint. So after we get rid of the gallons, gallons are on bottom, so we're going to put gallons on top. 1 gallon, and we're going to go to quarts. It's 4 quarts. And now we have to go from quarts to pints. So put quarts on top. 1 quart is 2 pints. Quarts cancel out. We now have ounces per pint. So on top we have 3.2 times 16. What is it? I believe 51.6, but I'm going to double check that. 51.2, sorry. That's 51.2 ounces on top. And on bottom, 1 times 1 times 4 times 2 pints is 8 pints. We divide that out. 51.2 divided by 8 is going to give us 6.4 ounces per pint. Number 3, both units are metric, so it makes life a little easier on us. This is 4.2 kilograms per 1 meter squared. And I'm just going to move my decimal points to convert each unit separately. I want to change kilograms into grams. To get from kilograms to grams on my measurement chart, it is 3 spots to the right. So I move my decimal point 3 places to the right. I have to add in the zeros to make it fit. That's 4,200 grams. Now we have to go from square meters to square centimeters. On our chart, from meters to centimeters is 2 spots on the chart, but since it's squared, every spot on the chart is 2 decimal places. So 2 spots on the chart is 4 decimal places. So we start here. There's no decimal there, so we assume it's at the end of the number, and we move it 4 spots to the right. So I have to fill in zeros. 1, 2, 3, 4. That is 10,000 centimeters squared. We divide that out. 4,200 divided by 10,000 is 0.42 grams per centimeter squared. Finally, we have 68 pounds per cubic foot, so that's 68 pounds over 1 cubic foot. Excuse me. I picked up a little bit of a cold shoveling the driveway yesterday. So anyway, 68 pounds per 1 cubic foot. We have to get rid of pounds. Pounds are going to become ounces. Put pounds here going into ounces. and 1 pound is 16 ounces. So the pounds will cancel out. And we have cubic feet that have to become cubic inches. Since cubic foot's on bottom, we're going to put that on top. 1 cubic foot is 1,728 cubic inches. So on top, we have 68 times 16 ounces. Oops. Cubic feet cancel out, so let's cross those off. So 68 times 16 ounces times 1. So 68 times 16 is 1,088 ounces. On bottom, we have 1 times 1,728 square inches. That's 1,728, so I got square inches, cubic inches. And now we divide that out. 1,088 divided by 1,728 gives us 0.6296, or 0.630. That's 0.630 ounces per cubic inch. So those are probably the most difficult types of conversions in this unit. The next thing we want to look at is we want to look at converting from metric to standard, or the other way around. We've done a little bit of this, but let's take a look here at some pretty standard or common rates that we have in the metric system that we might end up having to change over to, or in the standard system, that we might have to end up changing to metric. For example, 65 mph is a pretty common rate in our standard system. It really means, of course, 65 miles per hour. And of course, that really means 65 miles over 1 hour. And let's change it to kilometers per hour. So the hours don't need to change. I just need to change miles, kilometers. 1 mile is 1.625. Right, 1.6 kilometers. So the miles cancel out. I've got 65 times 1.6. This is 104 kilometers. On bottom, 1 hour times 1 is just 1 hour. So to divide that out, there's really nothing to divide. That's just 104 kilometers per hour. So most of our speed limits, the 65 mile an hour speed limits, are probably going to change either to 100 or 105 kilometers per hour if we make the change over to the metric system. Another common rate, a very common rate, let's say your car gets 23 mpg. Again, we know that means 23 miles per gallon. Let's see what that would be in kilometers per liter. So our 23 miles per gallon is really 23 miles for every 1 gallon. So we'll start with that. We got to convert miles into kilometers. 1 mile is 1.6 kilometers. Miles have canceled out. We're now in kilometers per gallon. We want to get kilometers per liter, so we got to get rid of the liter or the gallons. Gallons are on bottom, so we're going to put them on top. 1 gallon is 3.785 liters. So the gallons cancel out. So on top, we have 23 times 1.6 kilometers is 36.8 kilometers. On bottom, we have 1 times 3.785 liters. Now we have to divide that out. 36.8 kilometers divided by 3.785. Giving us 9.72 kilometers per liter. Doesn't sound nearly impressive as you start talking about 10 kilometers per liter versus 25 miles per gallon, but they are pretty close to the same. Looking on the financial side of things, let's look at the cost. Let's do a little research here quick. Let's look up current cost of gas in France. We'll go with France since it popped up here. I don't want their U.S. price. I want their... Okay, so 1.4 euros per liter is what they're saying there. Let's take a look. What is the conversion? U.S. dollars to euros. Right now, 1 U.S. dollar is 0.83 euros. So we'll use that equivalency. Notice we didn't have to have it memorized. 1 U.S. dollar equals 0.83 euros. So the dollar is worth less than a euro is what that's telling us. So to make this conversion, we're going to put this as 1.40 euros over 1 liter. We have to get rid of euros. So I'll put euros on bottom here. 0.83 goes with euros to the 1 U.S. dollar on top. So the euros cancel out. We now have dollars per liter. We want dollars per gallon. I'll put liters on top so they'll cancel out. Going into gallons. 1 gallon, 1.785 liters. Liters cancel out. And now we can multiply things out. 1.4 times 1 times 1.785 is $2.499. 2.499, which we're going to round to $2.50 because that's typically where we round dollars. On bottom, it's 1 times 0.83 times 1 gallon. This is 0.83 gallons. If I divide that out, 2.50 divided by 0.83, that is $3.01 per gallon. About where we're at right now. That's not as bad as what about 2 years ago. Actually, about 3 years ago now. That comparison was like $6 per gallon if you converted the European price to U.S. dollars per gallon instead of amount per euros per liter. Something seems off there. Let me double check my calculation there. I see what's wrong. This should be 3.875. That's why it seems fishy. Let me try that again. I totally screwed that up. This is 3.785, not 1.785 liters per gallon. I have to remultiply that top. So it's 1.4 times 3.785. That'll make way more sense. 5.29 or 5.30 dollars. And we'll divide that by 0.83, which is $6.39. That is way closer to what I was expecting to see. Sorry about that mix-up. That was just I screwed this up. It's almost 4 liters in a gallon. I had just 1.785. Little hamster stumbling on the wheel today a little bit, apparently. So anyway, other conversions that are very common. 1 kilogram is equal to approximately 2.2 pounds. It's technically 2.208 or something like that. But we go to 2.2 is close enough. So if you go to the doctor and you weigh 120 kilograms, how much do you weigh in pounds? Well, we take our 120 kilograms, put it over 1, put kilograms on bottom, going into pounds on top. 1 kilogram is 2.2 pounds. We multiply 120 times 2.2. I believe that is 264. Kilograms cancel out. Pounds. Over on bottom is just 1 times 1, so that's just 264 pounds. Sounds a lot better as 120 kilograms. Or, let's go the other direction. Someone that's 300 pounds, let's see what they are in kilograms. So 300 over 1. Oops, looks like my screen share stopped. Let me see what happened there. Let me re-go in. It looks like it's still not going. Let me reconnect with my tablet here, see if I can get it back in. There, it looks like we got the screen share going again. So we're putting the 300 pounds over 1. We'll put pounds on bottom now and kilograms on top. 1 kilogram is 2.2 pounds. So the pounds cancel out. We have 300 kilograms on top. 300 times 1 kilogram is 300 kilograms. On bottom, 1 times 2.2 is just 2.2. So we divide 300 divided by 2.2 is 136.36. We have 136.4 kilograms. We haven't talked much about length. When it comes to length, the one conversion that I have memorized is that 1 inch is 2.54 centimeters. And really, that's all we need. It's not that hard unless we start talking about miles. I do know, 1 mile is 1.6 kilometers. Because we get that large, I'm not going to convert everything to inches and go from there anymore. But for most everything else, the inches are just fine. For example, if I want to convert 30 feet into meters, well, I can convert my 30 feet into inches. Giving me 360 inches. And then I can convert my inches into centimeters. 1 inch is 2.54 centimeters. Inches cancel out. 360 times 2.54 is 914.4 centimeters. That's over 1, so that's just 914.4 centimeters. And then we have to convert it to meters. Well, that's just going to be moving a decimal point. From centimeters to meters is 2 spots to the left on the chart, so we move our decimal point 2 spots to the left. That's 9.144 meters. So 30 feet is 9.144 meters. Where things get a little tricky is if we're converting something like, let's say we're doing 2.4 pounds per cubic inch, and I want to convert that into kilograms per cubic centimeter. Now, actually, let's change this. Let's do it as grams per cubic centimeter. Will be a lot more accurate. Kilograms would be way large. It would be a tiny number if we did that. So anyway, we're going to start out with our 2.4 pounds over 1 cubic inch. Now I have to convert my pounds to grams, but I'm going to go pounds to kilograms here first. 1 kilogram is 2.2 pounds. Now I can just move the decimal point later to convert my kilograms into grams. So before I do that, I'm going to get rid of my cubic inches and go to cubic centimeters. But here's the deal. 1 inch is 2.54 centimeters, but I don't know the cubic. So I got to take my linear conversion. My length conversion is 2.54. And I have to cube it. So to the power of 3 gives me 16.387. And we're going to round off those last decimal places. So now this will put us, the inches cubed will cancel out, and we'll have kilograms per cubic centimeter, and then we'll move the decimal to make it grams per cubic centimeter. So on top, we have 2.4 times 1 kilogram times 1, so that's 2.4 kilograms. On bottom, we have 1 times 2.2 times 16.387 centimeters cubed is 36.05 centimeters cubed. I'm rounding just to a couple decimal places there. And now we have to divide that out. The 2.4 divided by 36.05 gives us 0.0666 kilograms per centimeter cubed. Now, I still have to make it into grams per centimeter cubed. I could have done it right here, I guess would have been a place to do it. Let's go back. I'm going to write this up top here. 0.0666 kilograms per centimeter cubed, because I want to show you something with that. So we're going to keep the 36.05 centimeters cubed for now. 2.4 kilograms to grams. Well, kilograms to grams is 3 spots to the right on the chart, so we move the decimal 3 spots to the right, and we fill in those zeros. That's 2,400 grams. If we divide that out, 2,400 divided by 36.05, we get 6.66 grams per centimeter cubed. Notice this number that we had for kilograms per centimeter cubed, since kilograms are in the numerator, in the top number of the rate, we can just move the decimal point. Move it over 1, 2, 3 spots. Oops, I put my decimal point in the wrong spot here. This is actually 66.6 grams per centimeter cubed. So it works the same way, whether we convert it after we divide it out or before we divide it out. We get the same number, 66.6 grams per cubic centimeter. For those of you in utility construction, you're going to be dealing quite a bit with electricity. You've done a little bit with your electricity and twisted pairs and stuff like that. Color codes and all that good stuff. When we deal with electricity, we don't use many of our main units. For example, for volts, we don't use decivolts and centivolts. We jump right to millivolts, MV, so V and MV. The reason we do that is because we want to be able to get out to our further metric prefixes. There's micro. Remember that Greek letter mu is the abbreviation for micro, so it'd be a microvolt. That's a millionth, remember. The milli is 1,000th, micro is a millionth. 1 billionth would be nano. So NV is a nanovolt or a billionth of a volt. You notice I'm leaving 2 spaces in between here because it's leaving, there's 2 decimal places. To get from volts to millivolts, you're moving 3 decimal places. We're just not doing the tenths or hundredths. We're going straight to the thousandths here. Same here, the 10 thousandths and 100 thousandths are skipped. We go straight to the millionths. Smaller than nano, we have a picovolt. PV is a picovolt. That would be a trillionth of a volt, or 1 millionth of 1 millionth of a volt. So pretty small. Going larger again, we're going to skip the deca and hecto and go straight to kilo. Kilovolt is 1,000 volts. We jump up to mega. Capital MV. Megavolt is 1,000,000 volts. And then, of course, we go to giga. GV is a gigavolt, or a billion volts. And then we would jump up to tera, which would be a trillionth, or 1,000,000 times 1,000,000 volts. We typically don't get that large in our voltages. And of course, that would also apply for amps or ohms for our resistances, or currents and resistances. So we need to, I put in 3 spaces in between each of these, or 2 empty spaces, so it's 3 spaces from one to the next. But you do have to remember that each of them is 1,000. So you could get away without putting the extra spaces in if you just knew that each space was 1,000, multiplying or dividing by 1,000. But if I have 0.028 volts, I don't like leaving it like that. When we're dealing with electrical values, we don't like having things that are smaller than 1 or bigger than 1,000. 0.028 volts would be better expressed. I move my decimal point over. I have to move it 3 spots. Remember, for our engineering notation, you have to move the decimal point 3 spots at a time. So I make it 28 millivolts. To get from volts to millivolts, it's actually 3 spots to the right. Vice versa, we might have something like 450,000 ohms. That upside down horseshoe is the symbol for ohms, for those who aren't familiar with it. Well, like we said, we not only do we not like things smaller than 1, like here, we don't like numbers to be larger than 1,000 either. So I'm moving my decimal point 3 spots at a time. 1, 2, 3. I can't go 3 more. It would be smaller than 1. So I got to stop there. That's 450. From our ohms, we went 3 spots to the left. So on the chart, we're going to go 1, 2, 3 spots to the left. That's kilovolts. So that's 450 kilovolts rather than, or kilovolts, kilo-ohms, rather than just 450,000 ohms. So the movement goes both ways. We can either move on the chart first to move our decimal point, or we can move the decimal point first and then use the chart to tell us what the units have to change. Here we move the decimal point 3 spots to the right, so we change our units from ohms by going 3 spots to the we move the decimal point 3 spots to the left, so we go 3 spots to the left on the chart to go from ohms to kilo-ohms. So there is a quiz out there for today. If you haven't completed it yet, please make sure you're taking time to do that. And then for homework, I believe we're finishing up the packet today. Page 238, 65 through 75 in the packet. And page 266, 63 through 90. There are some additional word problems in that packet that we have not got to. I would recommend you look through those and make sure you're good with those word problems. Make sure you really understand how the units work when we're doing applications. We do have tomorrow, we have one more lecture, one more set of units to talk about. Thursday, then, of course, is the Unit 3 test. So we'll be finishing up Unit 3 tomorrow and testing on Thursday, which leaves us, of course, we are actually just past the halfway point for this course, since this is a 12-week course. We are actually now halfway into week 7. So we are slightly over 2 days more than halfway through the course at this point. So with that, I'll let you guys get started. We have about 14 minutes left if you want to get started on your homework. I'll be on the network here to answer any questions as they come up.